All right, so we're going to work on finding the mean, median, mode, range, and then standard deviation. So as a warm-up, you're probably familiar with most of these. So use this data and find the mean, the median, the mode, and the range. So what we're going to be talking about is statistics. And statistics is nothing more than a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. And data is nothing more than the factual information. We see statistics everywhere. There's two things that can be considered when you're talking about statistics. You can talk about the population, which is an entire group of people, animals, and objects that information is desired about, or you can talk about a sample, which is really more just like a representative group. An example would be if I wanted to know what everyone in the United States felt about, I don't know, a certain sitcom, then I could go ahead and interview every single person in the United States and then do some analysis on that data, but that's not practical. So what's done more often is you'll take a representative sample. You'll take a group of people that you feel are representative of the thoughts of the entire United States, and you'll do some statistical analysis on that group. So you have measures of central tendency. This is what measures what's happening in the middle of your data. So one of them is the mean, which you should all be familiar with now. It's just the average. And you take the sum of the values of the data and then you divide it by the number of things you have. The symbol for mean is this little kind of looking like a little U character. And it equals the sum, which you're familiar from your sequences and series chapters. So the sum of all the x's divided by n, which is the number of things you have. And this is the mean of a population. There's also the mean of a sample, which is really the same exact calculation. Your calculator will use this x with the little bar over it for the symbol for mean. So if you found the mean of the data that I had on your warm-up, you would have added them all up, divided by 15, and you should have gotten 84.27. The median is the number in the middle when the data is arranged in order. That's key. It has to be arranged in order. The symbol is x with this little tilde above it. However, your calculator will just use MED for the median. And if you have an odd number of things, the median is simply the middle term. But if you have an even number of things, then you have to take the two middle terms and average them. So here is the data that we had earlier. We would have to put them in order. There is an even number of terms, so when I cross out one from each end of the list, you see I end up with 86 in the middle. So 86 is going to be what my mean is, my median is. The mode is the number that occurs most frequently. Now, you don't have to put the data in order to figure out the mode, but sometimes it's convenient to do so. So here again is all the numbers in order, and you can see that I have number 86 and 275. So in this case, I actually have two modes, 75 and 86. The range is taking your highest number and subtracting the lowest number. So 100 minus 52 is 48. That's the range. We also have measures of dispersion, so that will tell you how spread out your numbers are. It's also going to be called measures of variation. Range is one of those. So the bigger the range, the more spread out your data is, and the smaller the range, the more your numbers are close to one another. Standard deviation is another measure of variation. It measures how tightly packed your data is. And once again, you can find the standard deviation of a population, and this is the symbol we will use, sigma, or you can find the deviation of a sample. In this class, we will only be dealing with the population. The formula is the standard deviation equals the square root of the sum of your x's minus the mean squared all over how many things you have. This looks like kind of a complicated formula, but when you actually do it out, you'll see it's really not that complicated. This is your standard deviation of a sample, but again, in this class, we are not going to worry about that one. So let's look at an example. Here are some numbers. Here's our formula. The easiest way to do this out by hand is simply to first find your average or mean, because you need that in your formula, and then to make a table. Put all your x's down one side, and then put your x minus the average squared on the other side. So if my average is 5, to get the values in this second column, I'll say 1 minus 5, which is minus 4, square that, which would be 16. Go down to the next one. 2 minus 5 is negative 3. Square that and get 9. Go down to the next one. 3 minus 5 is negative 2. Square that and get 4. And so on and so forth all the way down your chart. Now, in the numerator of your standard deviation formula, it says to take all those x minus the averages squared and add them all up. Well, I have a column of all the x minus averages squared, so all I have to do now is just add up all these numbers. 16 plus 9 plus 4 plus 1, so on and so forth. So when I add them up, I get 68. So now the numerator of this formula is 68. So the standard deviation is the square root of 68 divided by 9, because I have 9 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. I take the square root of that, and my standard deviation is 2.7. Go ahead and see if you can find the standard deviation of these numbers on your own. So the mean is 57. If you make a chart, here's all of your x's. Here's your x's minus the mean squared. Now you're going to take all of those and add them all up. Put that back into your formula. Divide it by the number of things you have, which is 8, and take the square root. And so the standard deviation of this data is 27.7.